You're off out on a first date to the cinema. You've got hot tickets to the premiere of the critically acclaimed new release, Aliens vs. Giant Dinosaur Bees in Space 5, in 3D. But how to fill the awkward conversational vacuum before the film begins? What better way than to explain to your beloved-to-be how 3D glasses work? Things look 3D out here in the real world because you have two eyes. Hold your finger up in front of you, like this. Then close your left eye and look at it with just your right. And then swap eyes. Can you see that as you swap back and forth, your nearby finger seems to move against the faraway background? Judging the difference between the image seen by each eye is one of the ways that your brain constructs a three-dimensional model of the world around you. So, if you want to make a 3D movie, all you have to do is film every scene with two identical cameras, about the same distance apart as human eyes. But when you're playing it back, how can you make sure that the right image gets to the right eye? We're going to need a property of light. Like jam, light comes in different flavors, but unlike jam, there are only two. These flavors are called polarizations, and they arise because light is a wave. If I shone a beam of light at you guys now, it could either wobble from side to side, that's horizontally polarized, or up and down, that's vertically polarized, as it traveled forwards. Most light is a mishmash of the two, but we can use a polarizing filter to select just one flavor of light at a time. You could even make a pair of 3D glasses, which use horizontally polarized light for the left eye and vertically polarized for the right. And then you could play the film back on a corresponding pair of projectors. Sadly, there's a problem with this, and the problem arises if you tilt your head. Imagine you're leaning on your date's shoulder, and they're a bizarrely long way away. Maybe this date isn't going so well. So your head is at 90 degrees. You'll get the left eye's image through the right eye, and the right eye's image through the left, which will make you feel sick, and you'll probably vomit all over their lap. And you don't need a scientist to tell you that that is a cinema date disaster. The solution is to use circularly polarized light, a clever mixture of horizontally and vertically polarized. Circularly polarized light spirals through space instead of wobbling, and we could use it to make a different pair of 3D glasses, one which used light spiraling clockwise in the left eye and anti-clockwise in the right eye. And this comes with a big advantage. Clockwise and anti-clockwise don't change as you tilt your head, so the correct information is always delivered to each eye. So, no vomiting and the perfect icebreaker. That's how science could save your date at the cinema.